Now let's talk about domains of rational functions. So think of what the domain is. These are the input values or the x values you can plug into a rational function. So the domain of a rational function includes all real numbers except those that cause the denominator to be 0 because we can't divide by 0. So that's our real goal, is to find out where the denominator would be 0. So you set the denominator equal to 0, solve to find the x values that cause the denominator to equal 0, the domain is all real numbers except those found in step 2. So for this example, we take the x squared minus 9 and set it equal to 0. That's a couple ways to do it. You could factor it. You could just say x squared equals 9. And then taking the square root of x squared and plus or minus the square root of 9, because we're solving an equation, x equals plus or minus 3. So the domain for this would be negative infinity to negative 3, union 3 to negative 3 to 3, union 3 to infinity. Just to give a little image of what's happening here. Now some people might look at this and say, and this comes up later on for a problem, that x plus 3 over x plus 3 times x minus 3. Yes, you could reduce this out, and that's what we're going to get into with the removable discontinuities, but it's still in the initial form of the problem. This x plus 3 is going to make that negative 3 would make it 0. So we still have to exclude it. So our graph would look something like, let's call this 3 vertical asymptote here. So there wouldn't be a vertical asymptote at the negative 3, but the curve will have a hole. And like I said, we'll talk more about this in a few videos from now. You get a hole there, and you get this here. Okay, but this is the domain that we're after. I'm hoping that's not cut off. Let me see if I can adjust the image size, the image location. There we go. Okay, that's it for this video.